New book out that is really interesting if you give it a minute. The electromagnetic field, the electromagnetic force that created the modern world and could destroy it. The book is called The Spinning Magnet. Alanna Mitchell is our guest. She is a science journalist. Alanna Mitchell, welcome to Big 550 KTRS.
It's great to be here.
It is published by Dutton, and the reason why I bring that up, that is a division of Random House, which is a very credible publishing house, which means this is a very credible book. You are talking about something that sounds so absurd that it's on the fringes of the internet, things that people would never believe. I had to double check to make sure this was a legit topic and a legit book before I decided to put you on.
Listen, I felt the same way when I started to research it. I just thought, really? Really? Is this true?
Okay, good. So I'm not the only one who thinks you're crazy. All right, fair enough. The book is called The Spinning Magnet. Alanna Mitchell, explain the premise of the book.
Okay, well, my research started when somebody said to me, our planet is a great big magnet with two poles, the North Pole and the South Pole. But sometimes those poles switch places. So north becomes south, south becomes north, and it could be happening again. And so that's where I started with the research on this book.
Now, I remember from science class them telling us that the poles reverse themselves. Do we have any idea why they reverse themselves?
Well, you know what? Scientists have a pretty good idea about why that happens. So our Earth's magnetic field is generated within the core of our planet. So there's a solid metallic core, and then there's an outer core that is made of the same stuff, but it's molten. It's not solid. It's molten. It's moving, and it's turbulent. And that's where our field, our Earth's magnetic field, is created. And it's this huge, strong field that goes out into space and protects our planet from solar and galactic radiation. So sometimes within this outer field, outer core is very, very turbulent, and sometimes it gets extra turbulent, really disturbed, and this two-pole system there are these like factions of other magnetic entities that are trying to destabilize this two-pole system, and sometimes they win. When they win, the two poles change places. They go on this long journey, this long migration to switch to opposite sides of the planet from where they are at that time. And that's happened hundreds of times in the planet's history.
All right. Now, Alanna Mitchell, the book is The Spinning Magnet. How do they know that the last time this happened was 780,000 years ago? Google wasn't around. How do they know that?
They can tell from a record in the rock in the Earth's crust. So the Earth, so certain types of rocks that have iron or other, metallic properties lay down they become sort of like fossilized magnets within the crust, and they tell not only how strong the Earth's magnet was at that time, but they also tell what direction the magnetic field was running, and that's where the poles come in. So they can tell where the poles were at the time that this magnetic fossil in the crust was created.
So you're saying that the magnetic poles don't necessarily switch, but they also go left and right and east and west?
When the poles, so when this big disturbance happens within this outer core, so when that happens and our dominant poles, the north and south, start to move, what happens is that there actually at that point are not only two poles, but 4 or 6 or 8, or there could be any number of pairs of poles as these other magnetic factions gain prominence within the field. So yeah, they move from they migrate right across the surface of the planet to the opposite sides, the dominant ones, and then they sort of snap back into place and reassert their dominance, and then we have a two-pole system again.
Okay, that's all well and good, Alanna Mitchell. The book is called The Spinning Magnet. Interesting, kind of like the full solar eclipse this summer was interesting. I don't really use a magnet, or I don't really use a compass to figure out where I'm going. I know where I'm going. Why is this such a big deal?
It's a big deal for one thing for me because it's fascinating. But for another thing, when the poles are switching places, the field, this big magnetic shield that protects us, goes down to about 10% of its usual strength. So that means that more solar and galactic radiation is able to get closer to the surface of the Earth. And the concern that scientists have about that is twofold. The first part is that leaves us exposed to solar storms. So when there are big flashes of energy, massive streams of energy to come off the sun, unusual ones, that could scorch our electromagnetic systems on the Earth. So the electric grid, the satellite systems, GPS, all that stuff, they could be very, very disturbed, and we could lose. The prediction is that we could lose our electric grid for decades at a time.
Are you saying that
That's
our satellites in space are protected by the Earth's magnetic field?
Yeah, the satellites are within our magnetic shield. They're not in outer space. They're within our shield.
And so this solar flare is then repelled because of the magnetic field surrounding the Earth?
So the usual when there's a solar flare, which is this extra burst of solar energy, a stream, like a fast stream of energy, sometimes that can penetrate into the Earth's atmosphere.
Right.
Those are rare. They're not like every day. There's just general solar weather that is solar wind, they call it, that is always streaming off the sun and reaching the planet, and our field repels a lot of that. Some of it gets absorbed into the atmosphere, into the Van Allen belts, which are these sort of banks of radiation that also help to protect our planet. But sometimes those solar flares get so strong that they actually penetrate the closer to our planet's surface, and they have already destabilized parts of the planet's electric grid at times. There've been a handful over the past couple of decades that have already been strong enough to really disrupt things, and that's kind of a taste of what things would look like if that kind of solar storm happened and our shield were diminished because the poles were changing places.
What about
so
cell phones?
There are a whole bunch of things that would have to slot into place before we could really get damaged.
What about cell phones? If we switch the poles, what does that do for our cell phone service?
Right. Yeah, that they won't work.
Simple as that. Yeah. They just won't work.
Gone. Yeah.
What about
satellites and timing systems?
What about the lights in my house? Will the lights in my house work?
Well, not if the grid is gone. If the grid is gone, then no, they won't work.
Right. But electricity.
The grid is very interconnected. The electric grid on our planet is very, very interconnected. So, and there are all these transformers that are hard to replace. We don't have a big bank of transformers that we could just slot into place if a whole bunch of them were shot at the same time. So one of the ways that scientists are trying to figure out just right now, even though we have a fairly strong magnetic shield and we're not at huge risk of this stuff that I'm talking about, what they're trying to do is predict better when these solar storms are going to happen, or at least once they happen, say, oh, one is happening, and potentially shut down some of the grid as it gets exposed to the extra radiation. But they haven't perfected this yet.
But it's not just the solar flares, right? I mean, it's everything else if the magnetic fields decide to switch.
It's not. Well, the main risk is from energy from the sun and from the galaxy penetrating deeper into our atmosphere and possibly hitting the Earth. So you've got UVB radiation, ultraviolet. You've got, because the ozone layer will be damaged by this extra radiation. You've got solar energetic particles, which are very damaging to life. You've got bursts of radioactive energy, and these are some of those happen. They're in space all the time, and some of them are episodic. They happen in great bursts that are hard to predict.
All right, Alanna Mitchell, the book is called The Spinning Magnet, the Electromagnetic Force That Created the Modern World and Could Destroy It. I guess they're saying that this is overdue for a switch. How do we know that?
they aren't. Not everybody's saying it's overdue. I mean, it happened last 780,000 years ago, but it typically happens every 300,000 years. So that's one indicator. But the other thing scientists are looking at to try to predict this, and they cannot say, yes, this is happening. We are in the throes of a pole reversal. They will not say that. But what they will say is that we can't rule it out because there are three other things that are happening. One is that the north magnetic pole is really running around. It's really, it's racing around, and that's unusual. So it's moving. The other thing is that the field itself, our strength of our field, has diminished by about 10% in the last 140 years or so. And then they can see that there's a big soft spot, like a bruise on an apple, in the southern part of the hemisphere. So from Africa over to South America, it's weakened, and so it's like, think of an apple with a bruise in it. It's not repelling as much radiation from space, and so already there's extra radiation getting into the upper atmosphere of the planet, and that means, for example, that satellites that go through that part of the atmosphere are already shutting down to preserve their memory. So that's one of the things that's happening. And that thing, which is called the South Atlantic Anomaly, is already it's stronger just in the past couple of decades. It covers about a fifth of the Earth's surface. It's becoming more disrupted, as we speak.
Are you
so
saying?
Hold
on, because I'm short on time, Alanna. Are you saying that the North Pole in the North Pole is not at the North Pole, but it's sort of moving around the North Pole?
The magnetic North Pole is moving. It moves all the time, but right now it's moving really, really fast. So at one time, the North Pole, when it was first discovered, and that was in 1831, was actually on the mainland of Canada when it was first discovered in 1831. It's moved now. It's almost in Siberia. Like it's way, it's moved tremendously. It's moving all the time, but right now it's moving really fast.
So when I take out my compass and find north, I'm ultimately going towards Siberia?
Yes, that's correct.
Huh. Who knew?
Yeah.
All right. Alanna, any movie interest in this? This would make a great movie.
Yeah, I don't think so.
No?
The book's only out today.
All right. Well, mark my words. Somebody from Hollywood's going to turn this into a blockbuster. This is a great story and a great, you put it in such a way that sort of makes science fun and interesting. The book is called The Spinning Magnet, Alanna Mitchell, the electromagnetic force that created the modern world and could destroy it. Alanna, good luck with the book. Thanks for checking in.